Okay, so let's look at data loss prevention with a focus on databases and web losses. These account for a great deal of the data that can leak from a site, and also there can be large-scale loss of data from the client's data too. So we need to make sure that we can detect any sort of database and web losses. So we'll focus on SQL misuse and also on cross-site scripting. And in this lecture, we'll do a little bit of web scanning with inside the practical element of this, and then we'll just touch on honeypots at the end. Okay, so OWASP define their top 10 of web vulnerabilities. That includes injection, broken authentication, and session management, cross-site scripting. So the two we'll focus on this unit are these two, but there are a whole other things such as direct object references. That's typically to say Windows components, DLLs, and so on. Misconfiguration of security, sensitive data exposure, the missing function level access control means that the actual entity doesn't really have the right levels of access control on it. So we might be running a web process with too high a privilege. Then we see cross-site request forgery, where an intruder could play back some sort of session details or a cookie to be able to get access to the user's data. Known vulnerabilities, Flash especially and PDF Reader are two well-known components with vulnerabilities, along with Java plugins. That's the three main vulnerabilities that we have. And then unvalidated redirects and forwards are problems. Okay, so the two that we'll focus on mainly are injection and cross-site scripting. With injection, what happens is that the intruder forces some sort of script into an interpreter. So we normally get an interpreter. The user posts or gets a URL to the web service. The web service is often linked to a database and also runs an operating system and returns back some HTML code to the user. So in this way, SQL or the commands themselves could be injected into the system to get access to privileged operating system calls or onto the database. For the other one, and this is a pretty severe one, we have a cross-site scripting, and this is where some code is injected onto the site, which when clients, users access it, it could pull data from their own site, or they could be tricked into sending their data to another remote site. So we see this fairly extensively on sites, and it's a major problem where users are tricked, typically through phishing emails, to click on a link, or they see a web page, and then embedded in the web page is a login, and the login itself is actually going to redirect them to some external site and grab their user details. It happened on eBay that a malicious login component was actually added to the eBay page, and then when users tried to log into their eBay account, their user details were actually sent to a malicious site. So let's have a quick look at an example of this. Okay, so we have an email here. Okay, so this is just an example of a phishing email. It comes from HMR Customs. So when we actually look at the details of the email, we actually find that it certainly doesn't come from HMRC. So all the details look kind of correct. The email address looks okay, but when we actually see the original sender of the email message, it's coming from this domain here. Okay, which certainly doesn't look like a valid domain. We could do a quick lookup on that IP address 8069.77.165, but it's just coming in from some generic domain. and certainly isn't looking a valid email. So then when we actually click on the link here, the user will click on it and it'll open up a web page here. Okay, so everything looks fairly okay. We're using the same graphics and so on. Users really wouldn't know that they were not on the HMRC site. This is just a local file. But really, when we actually have a look at this in a bit more detail, we should be able to see. And what we're looking for is the form tag. Okay, so there we go. So anything between the forms will get posted into the website or our website here, and this is the website that it gets sent to. So when the user enters the details, you will see that things like mother's maiden name and address and date of birth and cardholder's name and email address and everything there really will get sent to this address here. Okay, so that means that the user's details are actually sent to another site. The user doesn't actually know that that's actually happening, but you can see that all the graphics that are used are actually from the right site, and we see things like the CSS again is used, the style sheets are all used from the actual proper site. Okay, so that shows an example of cross-site scripting. Okay, so let's look at SQL as our main concept that could be used to prevent or to allow large-scale data loss. Okay, so this is what's called a relational database. So in this case, we have a number of tables that are then linked. This defines a one-to-many connections. So each supplier can have multiple products. So we have a unique primary key here, and then that is then inserted into the products table to give us our linkage there. Okay, so this is defined as relational databases. So our supplier database itself might look something like this. There's the company name for our columns, and then each record is in a row, and so on. So we can create fairly complex queries across these relationships to be able to look at the products and who are the suppliers and when they have committed orders. SQL itself, the SQL commands, fairly simple, been around for a long time, but extremely powerful. So select is a standard command that we use, and then we actually define what we want to get. So if we say star, it will collect all of the columns within inside our table. Okay, so DB1 defines our table. We can have multiple tables if we want, and we can select from them. We can also have multiple databases where we say database dot table. So if the database was called my database and the table was called test1, then it'd be my database dot test1. But if we're already in the database, then we can just use the table name. Okay, so the basic commands that we're looking at for SQL are these: select, distinct, where, and so on. Then we can have a number of functions, that's average, and then there are string functions there. Okay, so let's have a quick look at what a database actually looks like. Okay, so you should find, we'll just discard that, and we'll just pull up a web browser, and we'll go to our security site. Okay, so you should be able to click on this link here, and this will give you a very basic SQL tutorial. Okay, so here is our database. Okay, so we can try some commands if we want to order in terms of the first name, if we want to order in terms of the surname. We can look at descending order, and we can order by age. Automatically we have a numeric value here, Okay, so we can actually say descending there. Okay, and that changes that like that. And then we can have various clauses such as select first name where the gender is male, Smith. Okay, select the first name where the gender is female. Okay, so and then we can actually add in some functions in there, and we can do counts if we need. Okay, so that's where the age is 30, age is greater than 30, and then equal to 30, and so on. Okay, so we can also use a wildcard, so this will match anything with SM and then anything after it. So this matches all the Smiths. And we can use regular expression type commands where that's A, an S, and a U. And you can see it's picked up the almond there. And so on. Okay, so on this page you can just modify it as you want. Okay, so you should be able to enter the commands like this. If we have a space on the on any of the variables, then we put a square bracket in them, so that we just run that just to make sure that it actually works. Okay, and it does. So we'll try test 2 and then addition. Okay, so you can either take the commands from here, or you can take them from, you can enter them yourself and then run the SQL then. Okay, so you can also click on here, and it should also give you the commands coming in there. Okay, so there are other commands that we can actually use. So we'll just have a look at some of those. Okay, so if we want to insert a record, then we can insert the data. Oh, sorry, if we want to search for a record, then we can actually search for something like this. So where the interest is in golf, soccer and rugby, we can do a search like that. Or where it's not in that's tennis and football. And we can also define a series. You can see there's the ages in there. Okay, so that allows us to search very fast for our terms on our database. So in this case it's where the country is the USA, or the interest is golf, gives us that. Okay, so let's go back and have a look at our other commands. Okay, so here we go. To be able to insert a record, then we can use this type of command. So let's actually change that. So let's make it Fred and Bob there, and we'll only give them 50 for the first test. So okay, so we'll run that, and then what we can do is that we can actually have a look at our database. Oh, let's give it a new number. So we've got to give a new number. So we'll make it 12. Fred and Bert and 50. Okay, run the SQL. That's fine. And then what we'll do is we'll select it back again, and there is our new record. Okay, so the database allows us to be able to insert records. We can actually delete a record if we want. So in this case, I forget what we put in for the surname, but we can go ahead and we can actually delete a record that we've just created. Then we can update. So let's say we wanted to change Freddie Smith's mark to a 50 for test 1. So the surname is Freddie Smith. Let's give him 70. Okay, so we'll have a look. And there we go. We've now changed all the Smiths for test 1 to 70. Okay, so we can create a table by using this. So we can actually add a new table onto our database with this, and we can obviously insert values as we've done there. So if we want to create my test, so let's call it my test 2. Okay, so then we can insert into my test 2. And then what we can do is that we can just have a look to see. There we go. There's a new record we've created. And if we don't like that, so we can get rid of Martin, my test 2. Martin, that gets rid of that record. And then what we can do in the end, we can drop my test 2 so that the table doesn't exist anymore on the database. Okay, so in this way we can actually modify, update, and so on for our data. Okay, so that's some of our examples. So if we can go and have a look at a test database. So we've set up some test databases. This is the North Winds database. So you can go ahead and we can have a look at the customers on the database. So there we are. Okay, we can also have a look at employees. And so on, and we can do some fairly complex. This is the relationships within the database, and we can find all our customers in Mexico. There we go. And we can look for all our customers in the US or the UK and count them, 7, and so on. So you can have a look at these examples in your own time, and see how they work. Okay, so obviously for data loss prevention, we need to really be able to understand and to be able to detect when there is the possibility of viewing SQL inside our network packets. So this shows an example of a Washout Trace where we can see some SQL commands on there. So what we'll do is we'll just pull up Washout and have a look at that. Okay, so MySQL uses port 3306 for its connection. So what we can do is we can just grab that, then have a look at the connection details there. And let's have a look at the hex dump. It's maybe easier for us to see what's going on. So the client is sending those commands to the server, and then the blue is what's coming back. Okay, so if we look at select database, show databases, show tables, and then we're creating a table here, the primary key and so on. We then insert into foo, a table called the foo is being created. it's inserting into foo animal name, the animal, then name, dog and Goofy, and then insert into, this is the column, animal and name, cat and Garfield. So we've just added 2 animals onto the database, and then what's happening here is it's then deleting from where the name is anything a 0, then a space, and then a 0, and then anything after it. So then anything in there will get deleted. And then we're going to count the number of records there. There's 1 record. And then we're going to select from foo, and we should be able to see what's actually on there. And the only thing that's coming, so we have our Garfield. Garfield is still there, but we can see that the first one, Goofy, has gone. Okay, and then a dog and Goofy, because of the deletion there. Okay, so we delete foo, and then we drop the table. Okay, so that's obviously there are certain characters that we can actually detect, like the double at is a good sign there. We can also detect the words like select. So we could use something like frame contains select. Okay, so we can see that should have detected select there. And insert. Let's see if I can find that. There isn't any insert on the database. And then this one here will detect the hash characters there, and we can see that that's managed to detect 2 of them from there. Okay, so there's the double at that it's actually detected, and then in the second one it's detecting these other characters that we get. Okay, so that Snort and Warshark and so on can pick up the possibility of these SQL commands, because maybe someone is injecting SQL into the database. Okay, so that shows an example of our regular expression of how we can search for it. Okay, so now let's look at code injection and to see what the basic threats are here for code being injected into a page. So the 2 main methods that we have when we're requesting a page from a website is get and post. The get is used when we enter in a URL. So this is the URL here, and the structure of the URL is that the parameters passed into the web service are defined between the ampersands here. Okay, so this is a variable name called username, this is Bill, this is a variable called password, and then this is Fred. Some other details get sent in there, really to do with the browser and what it accepts and what the basic type of the browser is, and so on. The other type that we have, we've seen it earlier with the form. So wherever we have form tags within an HTML page, then it will do a post. The post only posts the web components, the text boxes and check boxes and so on. It only posts that back to the server. So in this case, here are the values. So the URL itself doesn't actually change, but the value here that's getting posted in is google.com into the variable target.host. Okay, so what an intruder can do is either to modify the URL by injecting some values in here, or they can replay a post to be able to change the values that are actually posted in. So you'll actually see a lot of bots actually posting automatically onto a website, and then really just changing this value here. They might be trying to log in multiple times, and they'll be trying different usernames and so on. Okay, so this is the example that we'll do inside the practical session. So in this case, what happens here is that when we press the button, we actually found out that whatever appears there actually appears, whatever appears in the text box appears directly here, which means that the developer hasn't checked what is entered into the box isn't actually filtered. So in this case, JavaScript or other scripts can actually be entered into there. And what we have here is what's called an iframe. The iframe, in this case, I've put an iframe of a securitysite.com, and you'll see what happens is that iframe goes in directly into them. So the iframe is a particularly nasty tag that appears in a page, and part of the page, if an intruder can inject an iframe into there, then the rest of the page looks valid, but this part here can be from another site from them. So it's possible to insert JavaScript from a remote site into this box, and as you can see, we can insert an iframe into there too. So we'll look at that in more detail in the practical, and we'll have a look to see what we can actually do here. So this is Metasploit, and this is a typical package we would use to be able to test for our be able to learn how these things actually happen. So the last thing we'll look at is honeypots, and honeypots allows us to catch users and bots and malware on a network by setting up a honeypot, which means that they'll drop into the honeypot before they get to the production servers and so on. So they could be doing things here, and then we can detect it and make sure that they don't get to the other proper ones. So these honeypots will often have default admin passwords, weak passwords there, ports that are open to be connected to, and will generally react to any worms and viruses that drop in. Typically they might be at .1 or .2 in a network, or at the top end of the range, 254, 253, and so on. Network devices are often up at these top ranges there. Hosts are often down here. So we really want the intruder to drop into the first thing on the network and catch them there. So HoneyD is one, so we can get either what's called a high interaction honeypot. That's a real virtual machine that's running real services, and the users or the malware will generally drop into the machine, and it looks completely like a real production machine, but obviously the actions are being logged all the time. Or we have a low interaction honeypot, which implements some basic things like a login and looks like there's some data on the system. So we might open up certain ports for the honeypot to exist in. HoneyD is an example one. We can actually set up certain ports that are open on it, and we can even do things like set up a Cisco router to be able to simulate a Cisco device, in this case a PIX device. This is what the actual code looks like, the Perl script for the Cisco login. This looks like a standard login that you would get for a Cisco device from there. So let's have a quick look to see what a real honeypot actually looks like. So we'll just have a look at this web link here. So there are various honeypots that are existing across the world at any given time, and they're really looking at detecting the bots. HoneyMap is one. So with HoneyMap we see, hopefully in real time, the botnet activity that's going on across the world, and we can actually see these are the active attacks that are going on from there. So it takes a while to build up, but we should be able to see when these bots go and attack our fall into our honeypot. And you can see all these ones are existing just now. Oh, there's one from Russia, and over here in Brazil, Italy, Poland, and US, and so on. Okay, so that's an example how a honeypot can actually be used. It's really capturing attacks there. But if you're interested, there's a whole other series of these captures that you can actually look at real-time trends around the world. Okay, you can pick off each country and look at some key threats. Okay, so we've covered SQL misuse, some cross-site scripting. We'll do that a little bit more in the tutorial. We'll do some web scanning in the practical session, and we've had an overview of honeypots. Okay, thank you.